Hey everyone, this is Daniel, and you are watching a Kotlin tutorial on scope functions, which is a very interesting addition to the Kotlin standard library meant to increase your mental clarity and code flow. However, scope functions are quite unintuitive, especially if you're coming to Kotlin from a more mainstream language like Java, because we rely on functional programming, which is why this video exists. This video that you're watching right now is part of my Kotlin Essentials course, which is a very hands-on training on everything you need to know to be a productive Kotlin developer on any sort of platform, including Android, backend, or multi-platform. It's a very hands-on course. We write thousands of lines of code in the course. We have hundreds of examples and exercises, and we even write a mini project, which is a command line image processor, which I use on my own picture, as you can see here on the screen. So if you enjoyed this video, you might want to check out the course. I'm going to leave a link in the description anyway, if you want to check that out. In any case, let me go back to my development environment. Here I am in an application with a main method. Scope functions are some useful functions in the Kotlin standard library in order for us to perform chained calls. So this scope functions feature in the Kotlin standard library doesn't grant you any additional functionality that you couldn't do before, but it allows us to make the code easier, nicer to read and understand and whatnot. Let me show you. So let me demonstrate one of the first scope functions, and that is called let. So demo let. Now, let's assume that you have some sort of function. Let's call this obtain external list. And this is a function that you call from an external service. The implementation isn't really that important. Let's assume that this returns the list of 1, 2, 3, 4, 5. So you don't have access to the implementation of this method. Just know that this is something that you can call, and this returns a list of integers. So let me create a val called numbers as obtain external list. So you don't know how this obtain external list is implemented. You just have access to this method. Now, let's assume that you want to process this numbers value to perform some useful computations. For example, let's call this 10x numbers as numbers map n arrow n times 10. Then you want to print something. Maybe the 10x values are, and then you would interpolate 10x numbers. Then maybe you want to process this 10x numbers value to something else, like sum numbers. And maybe you would like to use a reduce, so numbers reduce. So have a, b, arrow, a plus b, something like this. Maybe you'd like to print something out. So this sort of step-by-step computations and step-by-step processing. So the sum of the 10x numbers is, and then I'm going to have some numbers. I'm going to use this 10x numbers as the reference here. So you get a list of numbers, you process them in a certain way, you print something out, then you process them further, you print something out. So some step-by-step processing. Now, the point is, for every step, you'd have to somehow refer to the previous computation step. So 10x numbers refers to this numbers list in order to perform the next step. The sum numbers refers to the 10x numbers intermediate variable in order to obtain the newest step of the computation. So there is a nice little function called let, which allows you to use the old computation for the next step. Here's what I mean by that. Let me give you a small example. Instead of saving this obtain external list as the numbers variable, you can say obtain external list dot let, which is a function that takes a lambda as an argument. And after you have the numbers, then you can perform the rest of your computations with that. For example, I'm going to perform the rest of my computations here inside the scope of let. So notice how I phrased that. You can perform the rest of your computations in the scope of let. So this is why let is a scope function. Now, at this point, you may want to pause the video and take a look at the difference between these two sections. And you may argue, especially if you haven't used chained computations a lot, that this style, the second style with let, is arguably more complex than the first one. It's much easier to simply specify the values and process them one at a time. So why bother? The difference is very small, and why bother with this let thing? The goal of let and the goal of the rest of the scope functions that I'm going to show you in this video is for mental clarity and flow, especially in chained computations. Let's assume that for these numbers that you obtain from an external list, you wanted to perform the following computations. You want to keep just the even numbers. So that's going to be a filter. Then multiply the numbers by 10. That's going to be a map. And then you would like to do a sort of average, but not by calling the average function. You would like to say list sum divided by list size plus 1. Maybe in your particular application, list size doesn't cut it. Maybe you want to include someone in your organization that you haven't counted, so you have list size plus 1. So the average function doesn't cut it for that particular implementation. So filter map and average would theoretically look something along these lines. So obtain external list, let me define a valid result as obtain external list, and then you'd say filter, and you'd have n arrow and mod2 is equal to 0, and then chaining that by doing map for every n that you obtain there, you'd say n times 10. And if you did have an average, like a regular average in the standard library, you'd say average. And you'll be done with it. But let's assume that this function here is not in the standard API of the list. So what do you do here to follow your chain computation? So you have filter, then map, then what? And that's where let becomes quite useful, because you can say .let, and given the list, you can say list.sum divided by list.size plus 1. And the flow is much, much nicer and easier to read and understand, especially in large code bases, especially in long computation chains. The alternative way without the chain would have been, let's call this step 1, as obtain, step 1 as obtain external list. Then step 2 as step 1, and then .filter. So I'm going to paste the filter. Then step 3, that's going to be step 2 .map. And finally, step 4 is going to be step 3 sum divided by step 3 size plus 1. So this is your regular computation chain by referring to the previous step on every next step. But this is far harder to read and understand because you need to refer to the right variable. So you need to keep track of which variable is being referred where. Not to mention that you can make a mistake. So for example, here in step 3, you might say step 2.size plus 1, and the compiler won't be able to catch that sort of error, and you'll end up with a bug in your code. Whereas with let, you only have access to the previous step so that you can compute the next one. So you may not really believe me at this point, given the fact that let is so new, especially if you're unfamiliar with the functional programming style, but this will become increasingly useful and increasingly powerful as you become more experienced with the Kotlin language. So trust me on that one. So hopefully I've broken the ice with the let scope function. There are multiple scope functions that Kotlin allows you to use. One is called with, one is called apply, one is called also, and one is called run. In fact, I'm actually going to continue with run. So run is the same as let, but the argument, or rather the run function, has access to the internal scope of the object on which you're running. In other words, the argument to run is the this object. Let me give you an example. So let me create a data class, and I'm going to call this person. We've done this before a bunch of times, but in this particular case, I'm going to make the name and the age variables. So name as a string, var age as an int, assuming that this person can change their name and the age. No code for the person class. I don't quite need that. I'm going to call this demo run. And let's assume that I'm going to create a little value. Let's call this Master Yoda. We love Master Yoda. So this is going to be a person with the name Master Yoda. And the age is probably 800 years old or something like that. Very old I am. Yeah, so in case you're wondering, I can say whatever Master Yoda says. Okay, so let's assume that saying Master Yoda dot age, let's assume that I'm correcting Master Yoda's age, like 800 to 850 or something like that. And Master Yoda dot name is going to be Yoda the Master Jedi. And finally, let's assume that I'm going to compute some sort of result, which is going to be a final string, Yoda the Master Jedi, and then 850 in the parentheses. So I'm going to say dollar, and in this case, I'm going to have master Yoda.name. And then in parentheses, I'm going to say master Yoda.age. So this result, this computation, is at or occurs after some setters, age equals 850, name is equals to something else, and finally I'm computing some result based on master Yoda. So every single time I'm referring to master Yoda as an explicit value name. Just like let, the run method, or the run scope function, allows you to run a chained computation where the result depends on the this instance. Let me show you how this thing would run. So I'm going to say result version 2 as master Yoda. So master Yoda, referring to that just once. And then I'm going to say run. And here, look at how IntelliJ figures out that this is a person. So instead of referring to master Yoda itself, you can simply say age equals 850. Then name is equal to Yoda the Master Jedi. And finally, you can return this sort of expression, but without referring to master Yoda name by simply using name and age. And in this case, I can remove the curly braces. So $name, $age in parentheses. So here in the scope of run, you have access to the internal data or the internal scope of the object on which you're calling the run method. So you have access to the internals of master Yoda as the this instance. And the end result of this whole expression is the end result or the end expression inside the code block. So this is the result of the lambda. So if you want to test out result and result version 2, you can print them out. So you can say print line result and print line result version 2 just to test whether these two things are the same. So demo run. So that is going to print us Yoda the Master Jedi with 850 in parentheses. Now, run is arguably the better choice instead of having Master Yoda being referred to all the time, because inside Master Yoda.run, you have access to the internal representation of this particular instance. So it's as if inside the run scope, you are a person. So run is very similar to let, only that the lambda that you're passing here as argument doesn't take any sort of argument itself, but inside the lambda, you can refer to the object on which you're calling run as the this instance. So this is the only difference between run and let. Now, the way run is implemented is as an extension method. This is how we can have access to the object that we're calling run on as this instance. So if you control click or command click on the run implementation, this is an extension method on any type T. So this is part of the Kotlin standard library, and run is an extension method on any particular value. So this is how run works. With is very similar to run, so similar to run, but it's not an extension method. And let me give an example of how with can work. Let's assume we have a data class. I'm going to call this gaming channel for sort of a chat room specific to an online game. Let's say val player A, which is a string, val, assuming I can spell string properly, player B as a string, and a var open, which is a Boolean. So this is a channel between two players playing an online game. So var open is Boolean. Let's also add a little method like fun message content string. And maybe this prints out something like print line. And I'm going to inject a little template here. So player A, and then to player B, and then the content. So this is how this thing would actually look like on the game UI, for example. Okay, let me create a fun demo with, and I'm going to create one of these gaming channels. I'm going to say val channel as gaming channel. Let's assume that we have Alice and then Bob as the players, and the open flag is true. Now, using this channel, once that we've defined the channel instance, we can then use the channel reference to call its methods. So this is the standard way of doing things. Channel.msg, let's say, build up your forces. And channel.msg, say, attack, or attack here. So all sorts of messages that these players may have. And finally, when you want to close the channel, you say channel.open is equal to false. So All in all, the regular way of accessing methods and properties on this sort of instance is by referring to this instance. Obviously, this is the standard Kotlin way of doing things. Now, the with function allows us to use this channel as a resource. So I'm going to say with channel, and then open some scope, and this reference is also available here, this gaming channel. So you can say MSG, build up your forces, MSG attack here, and so on and so forth. So inside the scope of with, you can access the methods of the object that you're calling with on. So let's say message attack here, and finally open is equal to false. So inside the scope, this is the object that you're calling with on. So it has a very similar semantic to run in the sense that this is the object that you have access to inside the scope of the method, but it's not an extension method like channel.run. You would say channel.run, and this would have been the equivalent thing. Instead of saying channel.run, saying with channel. So it simply reads a little bit differently. So again, the capabilities are not different either from the run method or from the standard way of doing things in Kotlin, but simply due to the fact that the code reads a little bit differently, we interpret the meaning of this code a little bit differently. So in this sense, with channel, we say that the channel is kind of like a resource. By using this channel, we have access to everything else that's inside. So with is actually being very useful when we use resources. And by resources, I mean all sorts of scopes, all sorts of coroutine scopes, all sorts of DSL enablers, all sorts of memory management, connection management resources, and things of that sort. With is very popular in those situations. And we're going to use with as we become more advanced, specifically with functional programming, context receivers, and even coroutines. So again, no new capabilities here. So there's nothing that you couldn't do before, but the code simply looks a little bit different. It reads a little bit differently. So this is why we have these scope functions, so that we can understand code a little bit differently depending on its shape. Moving on, we have apply. This is the same as run, but it returns the object that you're processing, not the result of the actual lambda. So in this case, we have master Yoda.run, and it returns the value of this string. In apply, you return the same instance after having applied the modifications. So it returns the same object that you're processing. Let me show you an example. So let's say fun demo apply. Let's build another person. So let's say Alice as person with Alice and age 23. And let's assume that we are setting or changing this instance. So changing this instance. Like Alice.name is Alice in Wonderland. And Alice.age is 24, because she becomes a little bit more mature after surviving the Wonderland. Well, the same sort of modifications, and specifically this is used for mutating the current instance. You can say Alice.apply, and inside this lambda, you have access to the person that you're working on. So Alice is equal to this in this scope. You can say name is equal to Alice in Wonderland, and age is equal to 24, and that would have been the same thing. Now, the result of this entire expression is the same instance of Alice after all the applied modifications. So I'm going to have, let's call this the new Alice, or the same Alice modified. Let's call this modified Alice as Alice.apply, because this is an instance of person. In fact, modified Alice and Alice are actually the same instance. So if I print line, modified as is equal to Alice, even the IntelliJ IDE gives us the hint that this is always true because it refers to the exact same instance. So same instance. So that's apply. This is the same as run, but it returns the same object that you're processing rather than returning another value that is the result of the lambda. Also is the final scope function that I wanted to show you, and this is the same as let, but the lambda doesn't return anything. So unlike let, where the lambda used to return something else, which we can then later use, also takes a lambda that returns unit, and the entire expression returns the same instance so that you can process it later. So the lambda doesn't return anything, and the expression returns the same instance. So also is useful for side effects. Let me show you an example of that. So I'm going to create a file. Let's call this demo also. And I'm going to run a very similar example to let. For example, obtain external list, and then doing the whole transformation chain, like filter on it mod 2 must be equal to 0, and then map on it times 10. And then finally, instead of computing the list sum divided by list size plus 1, the weird average that we were talking about, instead of computing it, maybe we would like to simply print it out and then returning the same instance later so that we can process it further. So you can say dot also, I'm going to say print line the weird expression, and the argument is still the same. So the shape of the lambda is the same as that in the case of let, but the result of the lambda is unit, not a particular value, so that we can also process the list further. Maybe for each print line it, which is the element in the resulting list. So this takes a lambda that returns unit, and at the end we return the same value, so returns the same list, and then that list we can use later. Again, for the sort of computation chains that we were used to earlier. Now, before wrapping up, there's only one last concept that I want you to take away from this video, and that is the notion of a context object. And the context object is the instance subject to the scope function. And this instance is being passed in various ways. For example, here under let, the context object is this entire expression on which you're calling the let function. And you have access to the context object as the argument to the lambda. So that's for let. In the case of run, the context object is the object on which you're calling run, and you have access to the context object as the this reference. And similarly, you have access to the this reference here, and you're passing the context object as an argument explicitly in the case of with. In the case of apply, you're calling the context object as an extension method, and you have access to the this reference as well. And the case for also, we go back to the let shape, and the context object is being passed as the argument to the lambda. So you have a variety of scope functions that you can use for various purposes. Hopefully these examples helped demonstrate. So don't stress about all these scope functions. We're going to increasingly start using them as we become more advanced in the Kotlin language specifically, and especially for functional programming. So scope functions have the goal to read the code differently and make it easier to understand, not necessarily to grant us new capabilities, because there's nothing that we can do now that we couldn't do before. It's just that the code takes a different shape, and it helps us to understand and see the code in a different way. Starting with let. Let allows computation chains and returns the value of the lambda that you pass as an argument. So this is one of the most popular scope functions that you can use. Run is the same as let, but you have access to the context object as the this reference, and this allows you to make mutations or call its particular methods. We have with, which is very useful for passing resources or for enabling DSLs or for context receivers, which is an advanced feature of the Kotlin language that we are going to explore later. With is particularly useful when we want to use an object or the context object as a resource. Another context function is apply, which has the same mechanism as run, but it returns the same context object, and is particularly useful for mutations or for applying things that don't return any meaningful value, like unit. And speaking of unit, we have the also function, which is the same as let, so it has the same shape, but the lambda that you pass as argument returns unit, and the entire expression returns the same instance so that you can perform further computations down the chain. So there you have it, folks, a comprehensive overview of Kotlin Scope Functions. I hope you enjoyed this video. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. And if you like, you can check out the Kotlin Essentials course. It's a comprehensive hands-on training on pretty much everything you need to know to be a productive Kotlin developer. Until next time, folks, this is Daniel signing off.